Hey, geometry, lesson 26 and 27 are both triangle congruency proofs. They're going to be sort of painful to watch because there's not all that much exciting happening. We're just doing proofs. Let's see, lesson 26 has how many proofs? 1, 2, 3, 4, 5, 6 proofs, and that's it. That's the whole lesson is 6 proofs. So, I would not recommend skipping them. You may see them again, and proofs are something that you really need to work through and just figure out a process for how to tackle them. So it's going to be quite boring for you to watch. Let's see if we can get through it. So first of all, you see all the stuff given there. Let's prove that those two triangles are congruent. Like I did in the last lesson, I'm going to push pause and write down the given stuff and just mark on the triangles what is given, and then we'll talk through the rest of the proof. All right, let's see what else we can do. I've marked everything and I've written down what is given. Now let's talk about those angles. When we know two things are perpendicular, we can say that the measure of the angles is 90 degrees, and we can do that for two of them. ABC and DCB. And our reasoning there is definition of perpendicular lines. So because they are both 90 degrees, you can also say that they are congruent, right? So the measure of ABC equals the measure of DCB. And that could be the transitive property. Transitive or substitution sometimes works for that. Okay, so we know ABC and DCB are congruent. So if DB bisects that angle, I didn't write that down as a given, so let me write that down now. DB bisects angle ABC and AC bisects angle DCB. That was given. Therefore, we know those angles are 45 degrees, because if we cut 90 in half, it gives us two 45-degree angles. So ABE and DCE are both 45 degrees, and that would be the definition of an angle bisector. Okay, hold on a second. I need a new page, and I want that drawing to come with me. Okay, so this is where we are. You already have everything else written down, I assume. So obviously I can't transfer over the words too. Let's see what else we know. I can say that these two angles are congruent because they're vertical. Because if you look back, what I'm trying to prove, let's get it in a different color here. Yellow looks like a good color. Triangle BEA, this triangle is congruent to this triangle. So I already have angle and side. I have an angle here and a side, but I need another angle. I hope everything didn't get too messy there. You can see what I'm doing. The measure of angle ABE is congruent to the measure of angle DEC because they're vertical. Vertical angles are equal. Now we have triangle BEA is congruent to triangle CED because of angle side angle. Next, given everything you see, let's prove that triangle ACE. Let me see if I can highlight. Let's see. Okay, so I've written everything that is given. In fact, I copied the drawing and highlighted the two triangles that we're trying to show that are congruent. So we see everything we have here. We're trying to show the triangles are congruent. So I've got a side and an angle marked congruent. They're not written in the proof yet, but I'm drawing, they're marked congruent. I have a side and a side and an angle and an angle. So I need another side, another angle, something. It is a right triangle. I could look for hypotenuse leg, but I don't know how to get this hypotenuse equal to that hypotenuse. But I can show that angle A is equal to angle A. Let's mark that in blue. So that would give me angle, side angle, angle, side angle. So let's see if we can do that. Let's work through the words we need. I do know that one is easy to write down. The measure of angle A is equal to measure of angle A because of the reflexive property. Everything else is given. All of these things right here are given. I do need to say that those right angles are congruent. So first of all, let's call them right angles because right now they're just perpendicular. The measure of angle BFA is equal to the measure of angle CEA is equal to 90 degrees. I don't know what that says. And definition of perpendicular lines. And then we're done. Triangle ACE is congruent to triangle ABF because of angle, side angle. That one was pretty easy once we knew what we were looking at. And what are some tools that I used? I've got 2 copies of the drawing. I marked what I knew, and then I tried to mark what I needed to know, because I only have so many triangle congruence criteria that I'm allowed to use. Okay, let's try another one. That whole given thing, we're trying to prove that JY is equal to KX. JY is equal to KX. So maybe if I can prove that those 2 triangles are congruent, let's do this. If I can prove these 2 triangles are congruent, then maybe I can prove that those sides are congruent because of CPCTC, right? It's one we love. Cool. All right. I'm going to push pause and write down what's given. Okay, let's see if we can make sense of this. I just went back to highlighting exactly what I'm trying to get congruent. Then I marked everything that's given. Okay? Still not quite sure where I want to go with this, but I do know that angle P is congruent to angle P. Okay? So angle P is congruent to angle P. So let's write that down. And that's reflexive. Hold on, I think I need 2 copies of my drawing again, so hold on a second. All right, let's do this again. So I know that this piece is congruent to this piece. Just copying everything that's over there. This piece is congruent to this piece because I just said it. Let's double arc that one. Nope. This angle is congruent to this angle, which I'm going to show using linear pairs and supplementary angles that this angle is going to be congruent to that angle. And then I'm going to have angle, side angle. Okay, if that didn't make sense, go ahead and rewind it and see if second time through will help it make sense. But I think we've got it. So I just said measure angle P is congruent to the measure angle P. Now let's say that that right there is given. So we're going to number that, angle 1 and angle 2. So I'm trying to get to angle 3 and angle 4. So we've already said angle 1 is equal to angle 2. Now let's go ahead and say that the measure of angle ZXJ plus the measure, let's see, ZXJ, that's 2. Plus 4, plus the measure of angle 4 equals 180. And the measure of angle ZY say ZYK, which is 1, plus the measure of angle 3 is also equal to 180. And that's the linear pair linear pairs are supplementary. Awesome. We're getting there. Okay. So now we can say that the measure of angle 3 is equal to the measure of angle 4. And we learned this rule in the last lesson. If two angles are congruent, their supplements are congruent. So there's my reason. Now I can say that triangle, let's name it in the right order, JYP is congruent to triangle, I went JYP, so KXP because of angle side angle. Need a new slide. Once you prove that two triangles are congruent, we can say that the corresponding sides are congruent. Okay, that one got a little messy. If it's hard for you to understand, you can star it and we can walk through it tomorrow in class together. Therefore, we got to the end. JY is equal to KX because of congruent parts, so congruent triangles are congruent. Okay? If you push pause and go back and look at the last picture, you'll see why. I'll go show you. Hold on. Moving on. Okay, number 4. Remember, I think I said there are 6. Yep, 6. Phew. Okay, I'm going to push pause and write down what is given. Okay, this is one strange proof. So we know what's given, and I'm trying to prove, let's highlight it here, I'm trying to prove that these two sides are congruent. And I know it's on a different triangle, but I'm hoping that might help you see it a little bit better. Let's look at the yellow triangle up here. If those two sides are congruent, then we know the base angles are congruent. So I have angle K and angle L. Because they're base angles of an isosceles triangle. Cool. Now let's use those parallel lines. If I have two parallel lines here in a transversal. That means angle K is congruent to angle Y too. So the measure of angle K is congruent to the measure of angle Y because they are corresponding angles. Something to know whenever you are given things like parallel lines in a triangle congruence problem, you're probably going to have to use the information, right? So we went ahead and used it. Now I have two base angles that are congruent down here. Okay, a base angle and a base angle. Transfer that down here. If I know those two are congruent, then I can say those sides are congruent, which is pretty darn exciting because a congruence, a proof that had me confused at the beginning, makes total sense now. So let's write it out. Angle, you need 3 letters for this one. X, Y, L is equal to angle L. That'd be our transitive property. And then we know that triangle XYL is isosceles. Can't spell. because you have base angles are congruent. So you can say that side xy is equal to xl because they're isosceles. As a note, you can also say that when you have two base angles that are congruent, we've learned that if base angles are congruent, then the sides opposite them are congruent. So you can use that for a reason too and take isosceles out of the picture totally. Number 5, given angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4, prove that AC is congruent to BD. Okay, it looks like if I can prove those two triangles are congruent, then I can go to the sides being congruent because of CPCTC. And remember, when two triangles share a side, you can say those sides are congruent. So let's go ahead and write down what's given. Okay, I can also say that BC is equal to BC because of the reflexive property. All right, so let's look at it. Do I have triangles that are congruent yet? I have side angle. Nope. So I have an angle and a side for this triangle and an angle and a side for this triangle, but that doesn't quite cut it. Let's see, what else do I know? Okay, I know that these angles are congruent because they're vertical. So let's say that. Angle AEB, so the measure of AEB is equal to the measure of angle DEC because they're vertical. So now I can actually say that angle A is equal to angle D. And work with me on the reasoning here. If I have two angles, that didn't come out right, two angles of one triangle equal to two angles of another triangle, can't spell, the third angles are equal. Because the inside of a triangle, the angles inside a triangle always equal 180. So if you've got two angles of one triangle equal to two angles of another triangle, then the third angles are congruent too. So if I look at this triangle right here, let's see, I have angle and angle. So I have, side angle, angle. That doesn't work. Yes, it does, because that doesn't spell a bad word. Yay! So right here I have side, angle 2, and angle A, congruent to side, angle 1, and angle D. I already have 1 is equal to 2. That's given. I have BC equal to BC. That's given, or that's reflexive. And then I did angle A is equal to angle D. So now I can say that triangle ACB is congruent to triangle DBC because of, let's see, what did I do? Side, angle, angle. Now we're trying to prove that AC is congruent to BD, and that is now true because corresponding parts of congruent triangles are congruent. One more! Alright, this looks like fun, doesn't it? Let's mark what we know. Got a measure of angle 1 is equal to the measure of angle 2. The measure of angle 3 is equal to the measure of angle 4. And AB is equal to AC. Now we're trying to get to ABD. ABD, triangle ABD is congruent to ACD. I don't know if this is going to make any sense. ACD. Okay, I already see the triangles share a side. So it looks like I can say these two things are congruent, which we always just mark. So if I can do side, and then I can do these angles, angle 1 plus angle 3 equals angle 2 plus angle 4. So I've got side and an angle. It looks like I just need another side, or sorry, another angle. Oh no, we know that AB is equal to AC. Let's mark that. I can do side angle side. Let's do it. Yay. Okay, I'm gonna push pause and write down what we know. Okay, that's all that's given. I can also write down that AD is congruent, or is equal to, sorry, AD is equal to AD because of the reflexive property. So now I can say that triangle ABD is congruent to triangle ACD because of side, angle, side. So that was step 1. Now we have to move down to how to figure out to say that angle 5 is equal to angle 6. Okay, so let's look at it. Okay, if those two triangles are congruent, I can also say that angle, let's just call it XDA, is equal to angle CDA. Let's go ahead and mark it in blue. These two angles are congruent. So now I can say that, oh, I'm in blue still. Triangle DXA is congruent to triangle DYA. If you look at it, DXA is congruent to DYA because of angle side angle. So now I can say the measure of angle 5 is equal to the measure of angle 6 because of CPCTC. Oh, I didn't put a reason up here. This one is because of CPCTC also. Phew, that's it. That's the last one. Congratulations. You guys did it.